All right, so another viewer's choice review video. So the question was, oh, I lost the question. Where are you, question? Confused on question 2 of the review pages. Wanted to go over it. Okay, so, oh, okay. Well, looks like I queued that up anyway. All right, so solve the following quadratic linear systems graphically, or I guess system graphically. All right, so I would offer that up as a typo opportunity for somebody if they'd like to earn some bonus credit. All right, so submit that on Remind, and I'll throw you a bonus point. First come, first served, as usual. All right, so what we need to do is create the graph. We could do that a couple of different ways, but since the word graphically was used in there, it kind of puts us in a spot where we may want to use the graphing calculator. All right. So I want to get my second equation set up. First one's good to go, so I can type that right in. Negative x squared plus 2x plus 5. My second equation, I want to subtract off the 1. Y equals x minus 1. All right. And then zoom 6 is the way to go, at least to get started. And the idea behind that is that it gives you a standard view of the window. A zoom standard. All right, I have mine set up for that. What we're looking for are two distinct intersection points between the two graphs. And it looks like we have those. All right, we have those, one in the third quadrant and one in the first quadrant. All right, so I just got to be able to flesh out where those points are. All right, I could do that a couple of ways. The simplest way would be to go into the table, second graph, go into the table and look for a commonality between your your y values for corresponding x's. So if you look in that table, you can see we have a common point for the graph at -2, -3. See the y values, y1 and y2 are the same. So we're going to have an intersection at -2, -3. And it also happens at the bottom of the screen there, you can see it happens at 3, 2. All right, I'm just going to do a quick screenshot of that because I want to keep that table and use that to help me create the graph itself. All right, I know what the graph looks like generally, but I need some points in order to come up with the graph itself. All right, so let me pop that table in here so I can reference it, and I'll put my calculator back on the graph. All right, so -2, -3. I'm gonna go red. Well, I'll go red for the line, and I'll go black for the parabola to try to keep it somewhat consistent with what we have on the calculator, or my calculator anyway. So -2, -3. 1, 2, 3. Beep, point. For the line is actually the second one. So let me go back to black. Back in black. Easter egg. The band name who sang that song or performed that song. I'll take that. First come, first serve for a bonus point. So -1, 2. 0, 5. 1, 2, 3, 4, 5. Forgive the shakiness. 1, 6. Then back to 5. Oh, a little schmear. Is this a bagel? No. And then the next one would be at for -3, so I'm going to plot that because we have some symmetry that we're looking for. I'll put the nice curvature to it in a couple of minutes. All right, as for the line, we have -1, -2, 0, -1, and so on. I'm kind of overdoing it with the dots here very much. It's really not necessary to put these many dots. I just do it for the sake of the fact that normally when I plot points, I do it by freehand. And so I end up having to connect the dots without a ruler, and it ends up being a pretty disastrous experience. That's exactly what it would look like, but then I have, for this app, my line draw tool, which usually does a decent job of getting it where it needs to go. I just need to kind of adjust it a little bit. But I do recognize that not everybody has a line draw tool. Although, honestly, I mean, I've mentioned this before, there's nothing stopping you from having it. You just need an annotation app, and this app here, GoodNotes, is it's not that expensive. It's $7.99. For a lot of people, that's like, wow, I'm not paying $7.99 for an app where I'm just writing stuff. There are a lot of free versions of this where if you just need to scratch some stuff down on a tablet, there's really no need to even pay $7.99. So get yourself an app for your tablet that allows you to annotate PDF files. I always post the PDF files on my website, and you can do what I'm doing here. Most likely, I was going to say maybe even better, but most likely even better. You know, and we're in a world now where this sort of proficiency with technology is becoming more and more valuable. So why not be one of those folks that actually knows what they're doing? There is a learning curve, as you can see, but, you know. And for me, if something looks a little too shaky, I just tend to make it a little bigger. That might be a little too big. However, very important thing to keep in mind, I don't care. Because the ultimate objective here was to come up with the coordinates of intersection. I wanted the points, sure, that gave you the parabola. That's all wonderful stuff too. You can highlight all that information. But I ultimately needed the intersections. Now you'll notice that we came up with that information way before we even produced a graph on paper, which makes it sort of annoying, I guess is the best way to put it. Because it's like, why do I have to do all this work if, you know, because the direction said so. And you'll find that that is the answer to a lot of the questions of why do we have to do this? Because you were told to. And in fact, if you just kind of get around to understanding that education has really evolved into you demonstrating over the course of around 13, if you're only going through high school, to 17, if you're only going through undergrad, to maybe more than that. Education has evolved into your ability over an extended period of time to demonstrate that you're able to follow instructions. Then you'll probably be in a good spot. All right. So anyway, that's the the graphical solution, the algebraic solution. I don't need my calculator anymore. We're going to use the substitution method. I'm going to go back to scratch here. I'm going to rewrite the second equation slightly, ever so slightly, as x equals y plus 1. Because that's telling me that every x is the same thing as y plus 1. So I'm going to write y equals negative meh squared plus 2 times another meh plus 5. Those mass are y plus 1s. All right. So this is one way to do it. There's other ways to do it. You could go with the solved version. You can take this and set it equal to that and simplify and solve. Either way, you're going to have to do a little bit of work. For this method that I chose, I'm going to do a little bit of algebra early on in order to kind of make life a little easier down the line, but it is what it is. Y equals negative y squared plus 2y plus 1, because you have to double distribute. All right, because it's really y plus 1 times y plus 1. All right, plus 2y plus 2 plus 5. Y is equal to negative y squared minus 2y minus 2 plus 2y plus 2 plus 5. All right, a couple of nice things are going to happen here. Not always going to happen, but in this case it does. I have a negative 2y and a positive 2y. They're going to cancel. I have a negative 2 and a positive 2. Those are going to cancel. All right. So I have y equals negative y squared plus 5. So I'm going to bring these two terms over to the other side. All right. So I'm going to continue my work over here. So we're looking at y squared plus y minus 5 equals 0. All right, and so factor it. Make an X chart if you want. Y and y. 2 times 3 is 5. Negative 2 plus 3 gives you the middle, which is a positive 1. Set each factor equals 0, you get y is equal to 2 and negative 3. All right, we also know that x is equal to y plus 1. All right, so x of 2 is going to be 2 plus 1, which is 3. X of negative 3 is going to be equal to negative 3 plus 1, which is negative 2. All right, so the x value corresponds with the y value. So this x corresponds with that y. So three corresponds to 2, just like this solution here. Negative 2 corresponds to the negative 3, just like this solution up here. Negative 2 corresponds to negative 3. All right, so we have two unique solutions, or two unique methods for finding the same solution. And there it is.